done, but I will show you once again. Okay, so let's start with shift registers. See, whatever in sequential circuits we have started with synchronous and asynchronous sequential circuits. So there we have studied about latches and flip-flops, okay, and the conversion of the flip-flops from SR to D and JK to T, okay. So like that we have seen the conversion of the flip-flops. After conversion of the flip-flops, we have seen how to draw the state diagram. Like given a sequence, how can we detect what if, let us suppose, if we want to what find out draw the state diagram for the sequence detector, how should we draw? Okay, so we have seen writing the state equations, then followed by the truth table, state, what is it, first step, what you will do, ma? When given a sequence, I ask you to design a circuit to find out a sequence 111 or 1101. అలాంటి sequence detectors ఇస్తే, what is the first step that you have to do? What is the first step that you have to do? Yeah, state table. Okay, you have to go with the state table, and then from the state table, what you will do? State diagram. Okay, state diagram. After the state diagram, what you will do? State equations. Okay, state equations tarvata, sorry, state diagram, state table, state equations. After writing the state equations, then what you have to do? You will draw the you will write the table where you will take the flip-flop excitation table. Okay, and then you will design your circuit. Okay, what may be, it is a sequence detector or whatever it may be. So we will, before that only, we would have discussed about shift registers and counters. Okay, shift registers, counters, or sequential circuits or sequence detectors, or whatever, all these are the applications of the flip-flops. Okay, these are the applications of sequential circuits. Let us suppose if we take about, we will discuss about the shift registers. So all to design all these circuits, we are taking flip-flops only. Okay, so group of flip-flops which are used to store multiple bits of data. Okay, and the data is moved from one flip-flop to another. It is called as shift registers. Okay, that means we are moving the bits, right shift, or we are shifting left, or okay, so whatever we want, if we want to shift 2 times, or if we want to shift 3 times, okay, if we want to shift in either way, okay, so we will take the help of shift registers. These shift registers are made up of flip-flops. Okay, so here we have different types of shift registers. So shift registers, basic classification is right and left shift registers. Okay, depending upon what these are the different types of shift registers: serial in, serial out, where we give the data, the input will be serial and output will be serial, and a bit by bit is come. Serial in, parallel out means serially one by one inputs we will give. Okay, for each clock cycle one input we will be giving, but the data will be parallel. At a time we will get the four, let us suppose 4 bits shift registers అనుకోండి, 4 cycles lo 4 inputs we will be giving, and the output will be at a time. Okay, so parallel in, serial out, we will be giving the parallel, we will be giving 4 bits of data parallelly. Okay, at a time we will be giving. So output will be serial. In each and every clock cycle we will get one output bit. Parallel in, parallel out means at a time we are giving 4 bits at a time, and at a time we are taking 4 bits out. Bidirectional shift registers mean either it will shift in 2 directions, left or right. Universal shift register, okay, universal shift register, it is having all the properties which is called as universal shift register. I will show you. First, we will discuss about the serial in, serial out shift register. Okay, serial in, serial out shift register. In serial out shift register, So see here, this is the date. Don't analyze this circuit. This is just the block diagram. I will show you the operation with the help of the next circuit. Okay. So this is serial input and serial output. So DN is the data input. So in the first clock cycle, whatever the data which we are giving, DN will be 0001. In the first clock cycle, the first bit will be stored in flip flop 3. In the next clock cycle, what happens is first bit is moved to FF2, and one more bit is the new bit will come to new data will come to FF3. In the third clock cycle, whatever the bit which is present in FF2, it will be shifted here. Whatever the bit which is present in FF3, it will be shifted here, and the new bit is given to FF3. And in during the fourth clock cycle, what happens? So FF1 data will be moved to FF0, FF2 data will be moved to FF1, FF3 data will be moved to FF2, and the new data is given to FF3. So like that you will get the serial output. Okay. Initially, when you are giving what basically when SISO, serial input serial output, is called as SISO. Single bit is shifted at a time, either to right or left direction. So clock will control the direction. Okay. So initially the flip flop, here I'm not showing you the reset, but initially the flip flop start in zero condition, reset to zero condition. That means, so what all the what outputs will be equal to zero. Now if you are passing the binary number, that I will show you here. I am passing the binary number initially 0000 only. So I am passing the binary data, D3 is equal to 1. Okay. So the first flip flop is set. Okay, when I'm giving D is equal to 1, the first flip flop is set. And here the word is stored in the register for the first falling edge of the clock. Okay, now 1000 during the first clock cycle. Okay, during the first clock cycle, so one only the first flip flop is set during the first clock cycle. Okay, whether it may be negative edge or positive edge, first clock cycle ki em avutundante only D3 will be stored with 1. So 0002 D2 D1 D0 will be 000. Okay, so in the next bit of the binary number is 1. Okay, so if we see in the second cycle what is happening, second cycle next bit also I am giving 1. What will happen is, whatever the 0 which is present, it will be whatever the 0 which is present in the flip flop 1, it will be shifted here. Whatever the flip flop now this 0 will be shifted here, this 1 will be shifted here, and D3 will take the new value. Flip flop 3 will take the new value 1. You can see here 1 1 0 and 0. Okay, so this is 1. So here the 1 1 0 and 0 will be the flip flop output. Next, these are the outputs at the each and every flip flop. And the next bit of the binary number, that is 1. 1 is passed to the data input 1. Okay, so here what is happening? Again, this 0 is shifted here. This 1 is shifted into this flip flop. 1 is shifted here, and new value D3 will take the new value. Okay, so 0. This is similarly what will happen. So last bit of the binary number is passed to data input 0, and clock is applied. Okay, last flip flop is set to 0. Okay, now see here, at each and every clock cycle, each flip, here only flip flop 3 is set. Okay, and here in the second cycle what is happened? Flip flop 3 and flip flop 2 are set. Okay, and again in the third cycle what is happening? Again the bits are shifted in the next clock pulse. Now here three flip flops are set. Similarly, if you are giving one more bit, all the four flip flops are set. What is your output will be equal to 1 1 1 and 1. Now you can see that this is negative edge triggered clock pulse I am taking. That's why you can see in this truth table during the negative edge of the clock. So what is happening? Q3 is equal to D2, Q2 is equal to D. What is initially 0 0 0 0? This is reset. During the first negative edge of the clock, what is happening? Whatever the data I am giving, 1 is shifted to Q3. Okay, so and only Q3 is set. All flip flops are in reset mode. During the next clock cycle, what is happening? I'm giving new bit 1. Okay, this new bit 1 is shifted to Q3. Similarly, this shifting will happen and Q1 is equal to T naught, like that shifting will happen. So at each and every negative edge of the clock, what is happening? One shift is taking place. Ardhamainda? Got got it? You can see here. So this is the stored word dn. Okay, q3, q2, q1, and q0. So 1 0 0 0 in the first negative. You're unable to see the presentation. Ashok, see. How about Prashant and Subramaniam and others? Are you able to see the screen?
Yes, ma'am.
Ashok, there is something. You log out and log in. Sorry. Log out and log in అవ్వండి లేకపోతే మీరు చూడండి you correct yourself. Okay. So yeah, fine. 0 0 during the first ఇక్కడ ఏంటంటే నేను I have this is word document actually. I wanted to give you this document అందుకే. So అక్కడ on the screen I cannot write with this stylus pen. Let's see. ఒకవేళ రాయగలిగితే it will be easy. Stylus is not working here. Okay. So see here, this is the stored word initially, and then so during the first negative edge of the clock, what is happening during the first negative edge of the clock? Positive edge ki icharu positive edge of the clock, what is 1000, and again during the next positive edge of the clock, what is happening? 1100. Again during the next positive edge of the clock, q1 is taking 1, and again during the next positive edge of the clock, q0 is taking 1. Okay, so next one is serial and parallel out shift register, and here the data is passed serially. ఇప్పుడు మనం serial and serial out చూసాము ఇంతకు ముందు. So it is serial in parallel out. Okay, data is passed serially and outputs are fetched in a parallel way. You can see this one. So serial input which we are giving here. So whatever the output which we are getting, this is the parallel output. Immediately I will get the output. Here it is a clock is given. What is that? Single clock is given as an input to all the flip flops at a time. Okay, here clear. When I am enabling this clear input, whenever I am enabling this clear, what is happening? All the flip flop states are reset to 0. అన్నిట్లో 0 store అయి ఉంటుంది when I'm enabling this clear. Okay, so if it is a positive edge triggered flip flop or negative edge during the edge of the clock, what is happening? Each and every bit serial input will be taken. Okay, initially I'm giving 1000. So immediately during the first clock edge I will get the output 1000. Okay, second clock edge key, what is the output I will get? 1 if I'm giving again second bit is equal to 1100, like that. Fourth parallel output, whatever you are getting at the fourth cycle, you will get the complete output. Okay, so next one this way. Okay, so you need to design your serial in parallel out shift register. Parallel and serial out shift register low. So we will be having parallel ga inputs at a time you will be giving. Whenever you are taking the output, you will be taking the this is your parallel in ఇది parallel in serial out now. So see, parallel in serial out, this title belongs to the next figure. So parallel in serial out lo input of the flip flop is the output of the previous input of the flip flop is the output of the previous flip flop. Okay, same thing, I need not explain you anything. Here you have shift mode. Shift mode lo second, fourth and sixth gates are inactive and the load and shift line are set to 0. So we can analyze by using this block diagram. Okay. So here what is happening is, so you are giving the parallel inputs B0, B1, B2 and B3. Okay. B0, B1, B2 and B3 you are giving. So shift load, you can see here the input, the shift load, one side is connected to ఇవి ఏంటో అనుకోకండి మీరు, these three are nothing but the 2x1 multiplexers. ఓకే, 2x1 multiplexers కి 2x1 multiplexers ఎందుకు పెట్టారంటే వెదర్ అదేమంటారు షిఫ్టా లేకపోతే లోడా. ఓకే, సో దీస్ ఆర్ ది 2x1 multiplexers. ఒకవేళ నేను ఒకసారి పెన్ యాక్టివేట్ అయితే చూస్తాను, ఒక్క నిమిషం ఆగండి. ఈజ్ ఇట్ విజిబుల్? కనిపిస్తుందా స్క్రీన్? కొంచెం జూమ్ చేస్తాను. ఓకే, దిస్ స్క్రీన్ ఈజ్ ఇనఫ్ అంటే ఇట్ ఈస్ సఫిషియంట్ ఫర్ యూ. చిన్నగా కనిపిస్తుందా మీకు? ఇప్పుడు వర్డ్ లాగా కనిపిస్తుందమ్మా మీకు? So see here, now you can see ma, this is shift or load. Okay, shift or load. So ఈ మూడు ఏం లేదు, these three are the multiplexers. Okay, these three are the multiplexers. So initially multiplexer ante what we need, multiplexer, this is your mux. Okay, so mux lo entante, so this is 2x1 mux. 2x1 mux, two inputs are there. Okay, so depending upon the select line, this select line is nothing but whether s is equal to 0, s is equal to 1. అంటే s is equal to 0 అయితే shift, s is equal to 1 అయితే load. Okay, like that I am taking the select line of the mux. Okay, so here what will happen is B0, B1, B2 and B3 are there. Okay, so B0, B1, B2 and B3. Shift or load, what I am doing is, in case this is equal to this is the input ma. Okay, so input into 5 tarvata, so this signal is given to chudandi, so inputs are 1 2 3 and 4, whereas load దగ్గర so inverted, next these inverted inputs are given to what you can see here, inverted inputs are given to only each second gate of the mux. Okay, inverted inputs are given to second gate of the mux. So if shift or load is equal to, sorry, if shift load bar ఇవ్వాలి ఇక్కడ, shift or load bar or shift bar or load ఇవ్వాలి ఇక్కడ. సో షిఫ్ట్ ఆర్ లోడ్ ఇఫ్ ఇట్ ఈస్ ఈక్వల్ అంటే లోడ్ అయితే 0 అయితే లోడ్ 1 అయితే షిఫ్ట్ అనుకున్నాం అనుకోండి. దట్ మీన్స్ లోడ్ when I'm giving 0 here, simply what will happen when I'm giving 0, only the inputs are loaded. Okay, so let us suppose 1 0 1 1, I'm giving b0 b1 1 0 1 1 ante, so where is here b0 1 0 1 and 1. So when I'm giving 1, what is happening? Okay, so these inputs are simply they are loaded. Okay, 1 0 1 1 are loaded. So whenever I am giving shift is equal to 1, okay, shift is equal to 1, what will happen? So what shifting operation will take place. Okay, so this is what the operation of what is this by parallel and serial out shift register. So whatever. Okay, fine. So shift and load. So here the output you can see, you will get the serial output. Okay, 1101 whatever shifting operation, how many times it will take place during each and every clock pulse, one single bit is shifted, you will get the output, the serial output you will get. Okay, so observe here very clearly shift or load. Okay, shift or load. So these are the B naught, B1, B2 and B3. B0 is directly given to flip-flop 1. So B1 you can see this is through this AND gate it is given. Okay. So whenever if whatever B2, sorry, what is B1, B2, B3. B2 also if you see it is connected to second, this is the multiplexer. It is connected to the second mux. B3 is connected to the first multiplexer. Okay, ఇక్కడ AND gates ki you have they are attached to the AND gates. So what is the nature of the AND gate? If any input, if any one input is equal to 0, obviously the output will be equal to 0. So if I am giving ikkada shift undi kada, shift nenu normal ga shift 0 ichchanu anukondi, that is 0 is there, what will happen? Simply there will be no shift operation. Whenever the shift is equal to 1, then only the shift operation will take place. Shift is equal to 1 ichinappudu AND gate inputs will be equal to 1. So what happens? Shifting operation will take place. Ikkada shift 0 ichinappudu nothing will happen. Okay, only the inputs are loaded. You should understand this concept here. Okay, so ఇక్కడ లోడ్ 1 ఇచ్చాను అనుకోండి, షిఫ్ట్ విల్ బి ఈక్వల్ టు, సో దిస్ మల్టీప్లెక్సర్ లో ఒకటి లోడ్ ఒకటి షిఫ్ట్. ఓకే, సో ఎయిదర్ లోడ్ అన్న అవుతుంది లేకపోతే షిఫ్ట్ అన్న అవుతుంది. సో ఎస్ ఇస్ ఈక్వల్ టు 0 ఉంటే, ఎస్ ఇస్ ఈక్వల్ టు 0 ఉంటే లోడ్. ఓకే, ఎస్ ఇస్ ఈక్వల్ టు 1 ఉంటే దిస్ ఇస్ షిఫ్ట్. ఓకే, s is equal to 0 ఉంది. ఓకే, s is equal to 0 ఉంది. సో సింప్లీ వాట్ విల్ హ్యాపెన్? సో ఇక్కడ నుండి వచ్చేది దిస్ ఇస్ వాట్, సో సింప్లీ B0 తర్వాత B1. సో ఫ్రమ్ B1 it will go here. So multiplexer will take this input. So and here also what will happen? Multiplexer ikkada what is D2 kada. So multiplexer will take this, and B2 kada, here multiplexer will take this input and it will load. Okay, so s is equal to 0 load. S is equal to 1 shift ante, so these inputs will be taken by flip flops, and during the clock cycle these bits are shifted. Okay, so this is the operation here. And the next one is parallel in, parallel out. Here the data is taken parallelly, and the data output also will take the parallel output. Okay, so parallelly you are giving the data B3, B2, B1 and B0, and you are getting the Q3, Q2, Q1, Q0 are the parallel outputs. Okay, so మీరు at a time inputs ఇస్తారు 1 1 1 1 అయినా ఇవ్వండి. So parallel outputs you will get. Okay, so during so shifted parallel outputs here Q3, Q1, Q2, Q1, Q0. Shift అయిన parallel outputs here taking. Okay, next one is bidirectional shift register. So here we have seen the shift registers, so either they shift right or they shift left. Okay, so here bidirectional shift registers, we can have two shifts. Okay, DR and DL. Data can be shifted right or data can be shifted left. Here we need to take one more input, that is mode select input, which we are taking. సో దిస్ ఇస్ సేమ్. ఇక్కడ మీరు ఏదో అనుకోకండి, గేట్స్ చూసి ఫ్లిప్ ఫ్లాప్స్ కి మధ్యలో మీరు ఏం పెట్టారు అని అంటే మల్టీప్లెక్సర్స్ పెట్టారు. మల్టీప్లెక్సర్స్ ఎందుకు పెట్టారు అని అంటే ఇప్పుడు టూ ఆపరేషన్స్ ఉన్నాయి, ఆ టూ ఆపరేషన్స్ లో ఏ ఆపరేషన్ పర్ఫామ్ చేయాలి అనేది దట్ ఈస్ ద డ్యూటీ ఆఫ్ ది మల్టీప్లెక్సర్. మల్టీప్లెక్సర్ విల్ డిసైడ్ విచ్ ఆపరేషన్ టు బి పర్ఫార్మ్డ్. ఓకే, సో సీ హియర్ దిస్ ఇస్ బైడైరెక్షనల్ షిఫ్ట్ రిజిస్టర్. ఒకసారి చూడండి, ఇది ప్యారలల్ ఇన్ సీరియల్ అవుటా, సీరియల్ ఇన్ ప్యారలల్ అవుటా. ఇన్పుట్ నేను సీరియల్ ఇస్తున్నానా, ప్యారలల్ ఇస్తున్నానా, అవుట్పుట్ ప్యారలల్ వస్తుందా సీరియల్ వస్తుందా చెప్పండి నాకు. బైడైరెక్షన్ షిఫ్ట్ రిజిస్టర్
parallel input madam. Parallel input
ఇస్తున్నారా, అవుట్పుట్ దిస్ ఇస్ this is mux 1, ఇది mux 1, this is mux 2, okay, and mux 3. Okay, so see here, shift or load. M is nothing but shift or load. This is M bar. ఇప్పుడు నేను ఇక్కడ ఏమి ఇచ్చాను అని అంటే m is equal to 1 I have given. Okay, m is equal to 1 ఇచ్చాను అంటే m bar will be equal to 0. Okay, m bar will be equal to 0. When m bar is equal to 0, ఇక్కడ వచ్చే output 0. Okay, so and here the output will be 0. Okay, and also here the output will be 0. Okay, and here also the output will be 0. Okay, so the output at ante these are all multiplexer will take the input from here. Okay, so multiplexer this is turned on. Multiplexer will be taking uh, this input, this input as the output. Mux will consider 1 gate 1 output. Here mux will consider gate 3 output. Mux will consider gate 5 output. Mux will consider gate 7 output. So here, so what is when m bar is equal to 0, what is happening? So input is whatever the input DL is there, DL input will be taken by this flip flop. Okay, so DL left shift, DL is nothing but left shift, right? If I am giving left shift operation will be taking, if I am giving 1 here, so left shift operation will be taking place. Whatever the bits which are there, bits are shifted left. Okay, similarly when dr is equal to 1, when this dr is equal to 1, so right shift operation will be taking place. Okay, right shift operation will be taking place. dl is equal to 1 అనుకోండి, అప్పుడు ఏమవుతుంది, what will happen actually when dl is equal to 1, what will happen actually? ఇక్కడ అవుట్పుట్ ఏమొస్తుంది చెప్పండి అమ్మా. What you will get? What is the output here? One. Here. ఇక్కడ ఇక్కడ ఓకే. సో 1000 not bit. It will take serial bit by bit, and what is happening exactly it చూడండి. So what is happening exactly, it is taking 1 by or operation. ఇక్కడ కూడా మీకు వచ్చేది 1 0 1 0 1 0, not able to write 0 and 0, you will get the same. Okay, you will get 1 0 0 0. Whenever you are giving some input, you will get serial data ne వస్తుంది. వచ్చిన తర్వాత whenever during each and every clock pulse, what is happening, the data is shifted left side. At each and every clock pulse, the data is shifted left side. So here if we are taking dr is equal to 1 and dl is equal to 0, what will happen, same the data, what it will take the flip flop 3 2 1 and 0 will take the data, but what will happen, the right shift will be taking place. Okay, right shift will be taking place. It all depends upon shift what dl and dr input which we are giving. ఒకవేళ ఇక్కడ dr1 ఇచ్చామనుకోండి, ఏమవుతుంది ఇక్కడ, what will happen, sorry, mode is equal to 0. So obviously what I am telling you, 8 6 4 2 will be equal to 0. So mode is equal to 0 ante whether it is shift or load, mode is equal to 0 is nothing but సో మీరు మార్క్స్ తీసుకున్నారమ్మా, 2 మోడ్స్ ఉన్నాయి. ఓకే, సెలెక్ట్ లైన్ ఇస్ నథింగ్ బట్ మోడ్ ఒకటి షిఫ్ట్ అవుతుంది, అంటే షిఫ్ట్ ఆపరేషన్ జరుగుతుంది. మోడ్ ఈజ్ ఈక్వల్ టు 1 అంటే లోడ్ ఆపరేషన్ జరుగుతుంది. ఇట్ డిపెండ్స్ హియర్. ఓకే, so when it is equal to 0, what is happening, when mode is equal to 0, what is happening, so shift operation, when mode is equal to 1, what is happening, right, simply the data is loaded here. Okay, confusion here, నేను కొంచెం పెద్ద డయాగ్రామ్ అయితే it will be easy and comfortable. So if you have anything here, if we have went anywhere wrong, you can tell me. Okay, so mode is equal to 0, this will be disabled and these are enabled. When these are enabled, what is happening, the left shift operation will be happening, the bits will be shifted left. Okay, so like this. So next one is universal shift register. Okay, universal shift register, it is a special type of shift register. It can load data in a parallel way and shift the data in both directions. Okay, parallel data loading, and you can shift left and right. Okay, so this is universal shift register. If you see the block diagram of the universal shift register, you can see here you have mode and parallel input you are giving. So these are the multiplexers. Okay, So if check this is right shift, you need to enable this one for right shift, and you for left shift, okay, left shift you need to enable this in for right and left. This is also one multiplexer. Okay, this is also one multiplexer you are taking. So for right shift and left shift, you are using these two nodes. Okay, this is the output which we are getting QA, QB, QC, and QD. Okay. So simply like the previous circuit only, but here you are giving parallel data. Uh, you are giving parallel data. So two inputs, right shift and left shift, we are giving to the mux, and mode also we are mixing here. When mode is equal to 0, when mode is equal to 0, what is happening? Mode is equal to 0. చూడండి ఇక్కడ but 0 ఇస్తున్నాను mode control. Mode is equal to 0 అంటే here mode is equal, this is 1. Okay. So దీనికి mode is equal to 1. Okay. So mode is equal to 0. Okay. So depending upon that right shift, mode is equal to 1 at the right shift, mode is equal to 2 left shift. Like that your bits will be shifted. Next one we'll see counters. My shift registers okay or not? You are satisfied or not satisfied? You tell me. Prashant, okay. And next, yeah. చూసుకోండి ఒకసారి. It's very simple. So next one is counters. So counters are used to count the clock pulses, which is very important for digital electronics. Why? Because the performance depend upon the performance will measure like how many clock cycles per second, like that. Okay. So counters are very important. Shift registers are also very important. So whatever, one second. Use it to measure the clock pulses. Okay, so counter is one of the big application of the flip flop. Okay, so whatever we are discussing, that the applications of the flip flops only, but counters are very important rather than other than all the circuits. Okay, initially if you see here, so the truth table of the counter, this is a 2-bit counter. Initially during the okay, first cycle, first clock, initially 0 0, first clock cycle 0 1, second clock cycle 1 0, third clock cycle 1 1, fourth clock cycle will be 0 0. This is the state. Okay, and the equivalent decimal counter input. Okay, so there are two types of counters: asynchronous counters and synchronous counters. Okay, asynchronous counters and synchronous counters. So asynchronous counters are also called as ripple counters. So, so here, why asynchronous counters are ripple counters means you can see here. So here the output, you can see two flip flops. Two flip flops are having two different clocks. So the output of the first flip flop is given as clock input to the second flip flop. Flip flop A output ni flip flop B ki clock laga icharu. So both are asynchronous. The timing will be different. Okay, which we have two flip flops. Apart from T flip flop, we can use JK flip flop also. Any flip flops can be used to design the counters. External clock passed to clock input of the first flip flop, that is flip flop A, and its output is passed to the అంటే ఒకదాని అవుట్పుట్ ఇంకో దానికి క్లాక్ లాగా వస్తాయి. They are not synchronous, asynchronous. Okay, so here we can design the counter using T flip flops, JK flip flops, okay, or D flip flops, whatever it may be. And this is the logic one which you are shorting TA and TB, and you are giving logic one. So these are you can see this is using JK flip flop. JK flip flop key we have set. So if you are giving JK shorting JK, when you are shorting together, it is nothing but a T flip flop. Okay, so clock input you are giving, the output Q of first flip-flop, you are giving as clock to the second flip-flop. This is nothing but Q0 and this is Q1. Okay, this is the 2 bit counter. Okay, this is the 2-bit counter using 2 flip-flops. So, మనకు 4-bit counter used కావాలి అని అంటే 4 flip-flops you need to use. Okay, 8-bit counter, similar 8 flip-flops you need to use. So mod 10 counter, mod 6 counter, mod 5 counter ఇవన్నీ ఉన్నాయి కదా. Mod is indicating the magnitude. Okay, so this is the counter during the first clock pulse. What is happening? This is the clock. This is the clock. Okay, so during the first clock, if it is a positive edge triggered, negative edge triggered, ఇచ్చారు. So now by seeing the clock pulse, we can see what is happening. Yes. So positive clock edge. Positive clock edge maybe. So 0 0 initially. During the negative edge of the clock, what is happening? Sorry, 0 1 0 during the negative edge of the clock, what is happening? 1, and again during it చూడండి. So this flip flop I am giving during the next after getting QA, the QA is given as clock to flip flop B. Okay, QA is given as clock to flip flop B. Here in this case also, whatever you are getting, whatever the Q which you are getting, okay, so this is given as a clock to flip flop 2. Okay, flip flop 2. So see here. So Q1, Q0 simply the input which you are giving. Q0 మీరు direct గా Q0 is nothing but the output of the first flip flop. Directly from clock toti sync ayi you are getting the output. But whereas Q2, it depends upon Q2 ki inti, this is the clock. Okay, Q2 ki, so whatever the Q1 which you are getting, for Q1 this is the clock. Okay, Q0 is acting as a clock pulse to Q1. Okay, so during the first initially Q0 is equal to 0. Okay, initially Q0 will be equal to 0, reset state. So during the negative edge of the clock, what is happening? Q0 is equal to 1, and again during the Q0 is equal to 1, and see here. Here initially Q1 is equal to 0. During the negative edge of the Q0, what is happening during the negative edge of the Q0? So Q1 is capturing this 1. Okay, Q1 is capturing this 1. So only thing what I wanted to tell you is, so Q0 is triggering at the negative edge of this clock. Okay, Q1 is triggering at the negative edge of Q0. Okay, Q0 is triggering at the negative edge of the clock. Q1 is triggering at the negative edge of Q0. Okay, so see here. Next. Okay, so during the negative edge of this clock, it is Q0 is equal to 0. Q0 is equal to 0. So and Q0 is equal to 0, and again during the negative edge of the clock, Q0 is taking the value 1, and again during the negative edge of the clock, the value is okay. So see here what is happening. This is the negative edge. Okay, this is the negative edge. During the negative edge of this clock, Q1 is taking the value 1. Okay, and again next negative edge is this one. During the negative edge of this clock, this whatever the one value which is taking, it is holding till the next negative edge. Okay, during this next negative edge, what is happening? Q1 is taking the value 0. Whatever the value which is taking, it will hold till the next negative edge of the Q0. Okay, you can see the figure. If I keep the figure and timing diagram in the same slide, that will be good. Okay, so whatever the values you are getting, the Q0, whatever the SC here, what so this Q0 is nothing but here it is acting as a clock to Q0 is acting as a clock to flip flop 2. Okay, clock. Okay, this is clock. Okay, so this is the timing diagram. From this you can see from MSB to LSB count 0 0 0 1 1 0 and 1 1. Okay, so it will give you the counter operation. So for each and every clock pulse, you can see the count is incrementing from MSB to LSB if you count. Okay. So this is asynchronous counter. Okay, asynchronous counter. So when both flip-flops in reset condition, QA QB will be equal to 0. When the first negative clock edge passes, what happens? First flip-flop will toggle. Okay, output will change from 0 to 1. The output, you can just read out all these things and you can understand the operation. Synchronous counters. So what do you mean by synchronous counters? A synchronous counter, the present counter output passes to the input of the next counter. అంటే దీని అవుట్పుట్ దాని క్లాక్ గా ఇచ్చారు కదా క్లాక్ ఇన్పుట్ గా ఇన్ సింక్రనస్ కౌంటర్ సో సేమ్ క్లాక్ pulse is applied. Okay, so you can see here the same clock pulse is applied to both of the flip flops. Okay, so both of the flip flops the same counter is applied. Flip flop 0 1 and 2, and here you are using an AND gate. You can see the signal diagram for this one. So during the positive first yeah, tell me. Okay, so this is the signal diagram for synchronous counter. Synchronous counter lo chudandi same clock is applied to the three flip flops. Okay, so same clock pulse is applied to three flip flops. Okay, so that is what is synchronous counter. If you can see understand the operation of the synchronous counter, so J and K are set to high. Okay, initially J and K are set to high. So similarly Q0 Q1 and here we have Q2. So Q0 and Q1 is given to AND gate. So if both are equal to, if any bit is equal to 0 on Q0 and Q1, obviously the third input K will be equal to J and K both are shorted, right? It will be equal to 0. If it is equal to 0, Q2 will be equal to Q2. For a JK flip flop, when for 0 and 0, you will get a Q, you will, the output will be same, the output will not change, Q2 will not change. Okay, Q0 and Q1 both are equal to 1, then only what will happen? Then only what will happen? So when both are is equal to 1, you are getting 1, you will get Q 2 bar here. Okay, so this way you can analyze this flip flop. See, all the flip flops are triggered at the same clock edge. You can see the signal diagram here. So during the first clock edge, negative edge triggered అనుకోండి. So during the first clock edge, what is happening? So this is flip flop. This is Q0 చూడండి Q0 Q1 Q2 and this is Q0 Q1 and Q2. Okay, Q0 Q1 and Q2. So during the first clock edge, during the first clock pulse, what is 1 0 and 0. During the second 0 0 1 and here ఒక నిమిషం 0 0 ఒక నిమిషం ఇక్కడ 0 0 0 0 0 1 yeah 0 1 0 and you can see the count here 0 1 1 here and you can see 100, 101, and this is 110, and this 111. Okay, so after 111, see 3 flip-flops, the maximum count will be up to 7 only. Okay, after 7, simply 000. Okay, so this is this way, Q0, Q1 and Q2. You should analyze the output like this. This is the timing diagram. I can go through all these things. So next one is ripple counter. Ripple counter is an asynchronous counter. Okay, clock pulses, they ripples through the circuit. Okay, if you want mod and ripple counter కావాలనుకోండి, so you need n number of flip flops. Mod 4 ante 4 flip flops, mod 8 ante 8 flip flops. Okay, like that. A counter can have two end states, and the counter resets to initial value. So what are the features of ripple counter? Different types of flip flops with different clock pulse are used. So ripple counter is nothing but an asynchronous counter. So these flip flops which are used in ripple counter, they are used in toggle mode. Here only the external pulse is applied to the only one flip flop. Okay, the counting sequence flip flop which external clock pulse is passed, it acts as an LSB. Okay, so here see ripple counter based on the circuit design. So up counter, down counter, up down counter. So binary ripple counter, or we can call it as two mod counter. Okay. So we can, this is an example for a ripple counter, LSP and MSP. So here we are using a clock. So whatever the output which asynchronous lag, whatever whichever the output which we are getting, so that output we are using it as a clock. Okay. So LSP to MSP count ఉంటుందన్నమాట దీంట్లో రిపుల్ కౌంటర్లో. సో యూ కెన్ సే 00 Q. This is the excitation table for JK flip flop. సో ఇక్కడ చూడండి మీరు రిపుల్ కౌంటర్ ఎలా వర్క్ చేస్తుందో. సో యూ కెన్ Q and this is 00 అయితే this are the clock pulses during the negative edge of the clock. LSP to MSP అన్నమాట 00 and this is 01. Okay, చూడండి ఇక్కడ 10 where you are getting, and this is 10. Okay, ఈ రెండు చూడండి, and 11. Okay, 111 it stands for 1. Okay, yes, again 11 2 bit kada, so 11 is a maximum count, 0001. Again this is the ripple count. So ring counter means what it will do. So it will so ring counter kuda entide shift, it is like a shift register only, but whatever only difference is whatever the output is there, again it will be fed back. Okay, so output is passed to the first flip flop. You can see here. సో నార్మల్గా మనకు షిఫ్ట్ రిజిస్టర్కి ఇక్కడ నుండి అవుట్పుట్ వస్తుంది కదా, ఈచ్ అండ్ ఎవ్రీ సైకిల్కి 4 బిట్స్ వస్తాయి కదా, ఈచ్ అండ్ ఎవ్రీ సైకిల్ యూ విల్ గెట్ ద షిఫ్టెడ్ అవుట్పుట్స్. ఓకే, సో వాట్ ఎవర్ ద అవుట్పుట్ ఈస్ దేర్, దట్ ఈస్ అగైన్ యూఆర్ ఫీడింగ్ బ్యాక్ టు ఫస్ట్ ఫ్లిప్ ఫ్లాప్. దట్ ఈస్ వాట్ ఈస్ కాల్డ్ రింగ్ కౌంటర్. ఇప్పుడు నేను 1011 ఇచ్చాను అనుకోండి, ఆ 1011 తిరుగుతూనే ఉంటుంది. ఓకే, సో ఇట్ ఈస్ లైక్ రొటేట్ ఆపరేషన్ లాగా, ఇట్ విల్ బి rotated. Okay, that is called ring counter. Ring counter it is used for rotate operation, and here you can see preset, clock, and preset is equal to 0, Q is equal to 1, clear is equal to 0, Q is equal to 0. Okay, so you can go through this operation, it's very easy. So ring counter lo meer చూడొచ్చు ఇక్కడ 10 10 00 ఇదేంటి షిఫ్ట్ ఆపరేషన్ అనమాట. అగైన్ మళ్ళీ ఇన్ వాట్ రింగ్ కౌంటర్ అయితే ఈ 0011 అగైన్ ఇట్ విల్ స్టార్ట్ మళ్ళీ 4 after 4 cycles again the same story will repeat in ring counter. Those types of ring counter, we have straight ring counter. Okay, so directly whichever the outputs which you are getting directly మీరు ఫీడ్బ్యాక్ ఇచ్చారు కాబట్టి, సో ద షిఫ్ట్, దిస్ ఇస్ ద డైరెక్ట్ రింగ్ కౌంటర్. Truth table you can see 1000 0100 మళ్ళీ ఇంకొక షిఫ్ట్ అండ్ అగైన్ వన్ షిఫ్ట్ అగైన్ వాట్ ఎవర్ ఇట్ ఈస్ దేర్ మళ్ళీ ఇది రిపీట్ అవుతుంది చూడండి అగైన్ ఇట్ ఈస్ రిపీటెడ్ షిఫ్ట్ అవుతుంది అగైన్ ఇట్ ఈస్ రిపీటెడ్. సో దిస్ ఇస్ ట్విస్టెడ్ రింగ్ కౌంటర్. ట్విస్టెడ్ రింగ్ కౌంటర్ ని స్విచ్ టైల్ రింగ్ కౌంటర్ అని కూడా అంటారు. ఓకే యూ కెన్ సింప్లీ సీ హియర్. This is also ring counter, but what is the difference is the straight ring counter direct the output is fed back directly. Okay, so the output of the last flip flop is passed to the first flip flop as an input. In twisted ring counter, ORI input is passed to uh, flip flops as a clear input. Here you can see circuit. Okay, so here whatever it is there, it is passed as a clear input. Their clear is different and this is ORI is different. Okay. So this is the corresponding output of the twisted ring counter. This is signal diagram. So next one is Johnson counter is also very similar to ring counter. So to the first flip flop as an input. But Johnson counter, the inverted outcome of Q bar of the last flip flop is passed as input. ఇక్కడ చూడండి whatever the last flip flop output. ఇది నార్మల్ గా మీ ట్విస్టెడ్ రింగ్ కౌంటర్ లో ట్విస్టెడ్ రింగ్ కౌంటర్ లో స్ట్రైట్ రింగ్ కౌంటర్ లో Q4 తీసుకెళ్లి డైరెక్ట్ గా మీ D1 కి ఇచ్చారు. Here the complement of the Q4 you are feeding back as an input to first flip flop. This is what is called as 4-bit Johnson counter. And here you can see the truth table of 4-bit Johnson counter. Okay, so you can understand each and every step is there. So the advantages are Johnson counter counts twice the number of the states. That is the advantage. So binary sequence la counting avvadu. That is the drawback of Johnson counter. Okay, you can take this shift registers and counters. See, tomorrow will be the tomorrow will be the last session for digital. So if you have anything, I already told you in the WhatsApp group లోనా లేకపోతే నేను I told you to the office లో నేను ఇన్ఫార్మ్ చేశాను. If you feel again that I have left anything, that any part syllabus is not covered, okay, you can write the topics and నాకు నెక్స్ట్ క్లాస్ లో అడగండి. లేదనంటే మీకు ఏమన్నా ఇంకా కవర్ చేయాలి అని అంటే కూడా యూ కెన్ ఆల్వేస్ టెల్ టు యూ కెన్ గివ్ యువర్ ఫీడ్బ్యాక్. యూ కెన్ గివ్ యువర్ ఆనెస్ట్ ఫీడ్బ్యాక్ టు ఏమంటారు మల్లికార్జున్ సార్ ఆర్ మేడం. అండ్ so tomorrow will be the last class. If anything is left, I will be covering in tomorrow's class. And quickly the నేను ఇంకా దీనిలో వదిలేసింది ఏంటిది అని అంటే ASM algorithmic state machines ఒక్కటే. ASM charts that is also very easy. అదొక 10 minutes లో అయిపోతుంది. ఇది సీక్వెన్స్ డిటెక్టర్స్ అవి స్టేట్ టేబుల్ చెప్పేటప్పుడే ఎవ్రీథింగ్ ఈస్ కవర్డ్. ఓకే, టూ ఆర్ త్రీ ఎగ్జాంపుల్స్ విచ్ వీ హ్యావ్ సీన్ దట్ ఈస్ ఇనఫ్ ఫర్ స్టేట్ మెషిన్ ఫైనైట్ స్టేట్ మెషిన్స్ కి సీక్వెన్స్ డిటెక్టర్స్ కి ద సేమ్ వే యూ హ్యావ్ టు ఫాలో. సో కౌంటర్స్ షిఫ్ట్ రిజిస్టర్స్ అయిపోయింది. తర్వాత మెమరీస్, ఐ థింక్ మెమరీస్ ఆర్ not a part of your syllabus. If they are there, I will explain, but I will give you the notes. Whatever it is required, I will share the material with you. మళ్ళీ దాని తర్వాత కాంబినేషనల్లో అయినా ఇంకా దేంట్లో అయినా ఏదన్నా వదిలేస్తే కానీ నాకు చెప్పండి. సో by tomorrow we will close this digital. ఓకే అమ్మా, హ్యామింగ్ కూడా హ్యామింగ్ కోడ్ ఒకటి. ఓకే, ఇంకా మీరు ఇంకోటి ప్రశాంత్ యాడర్స్ తర్వాత డికోడర్ డిజైన్ యూజింగ్ మల్టీప్లెక్సర్స్ ఇవన్నీ అన్నారు కదా, అవి చెప్పాను నేను. ఒకసారి చూడండి, ఒకసారి లాస్ట్ వీడియోస్ లో వన్స్ యూ చెక్. ఐ థింక్ ఐ హ్యావ్ ఎక్స్ప్లెయిన్, నేను నాకు తెలిసి అయితే, బట్ స్టిల్ ఐ విల్ మీకు కావాలి అంటే మళ్ళీ చెప్పండి లేదు. సో ఇది క్లోజ్ చేసేస్తే కనుక వి విల్ స్టార్ట్ విత్ వెరిలాగ్ సెషన్స్. Okay, now I'm closing the session. You whatever is there, you can share with మేడం అయినా మల్లికార్జున్ సార్ తోటి అయినా షేర్ చేయండి, ఇది బాగుంది, ఇది బాగాలేదు, ఇది మళ్ళీ కావాలి అని అంటే. సో దే విల్ గివ్ మీ ద